This new video is another in our series on doing things with geometric algebra. It presents solutions to the exercises in Hestenes' geometric algebra treatment of constant acceleration or parabolic motion, which is found in his book New Foundations for Classical Mechanics. And this document is the final part of our four-part guide to Hestenes' treatment of parabolic motion, and links to the previous documents and videos in this series are given in the description. We prepared this guide for students and especially self-learners, and also for prospective teachers who are weighing the costs and benefits of teaching a geometric algebra approach to physics. We want to make our guide as useful as possible, so please be free with your critiques and suggestions. They'll help us to make a better resource for the students. So Hestenes' solutions to his exercises are very brief because of typical space limitations for textbooks. In contrast, our solutions are going to be quite detailed, and they will address possible doubts that students and prospective teachers might have regarding Hestenes' solutions. So let's go ahead and look at the exercises and make some comments on the solutions. We'll expand this a little bit so you can read it better. The first problem asks you to derive an expression for the time of flight to a target. And the solution to that is nothing spectacular. It's fairly straightforward. Similarly, exercise 2 asks us to derive a somewhat different expression or quadratic equation for the time. And Hestenes points out that this version does have some serious drawbacks. Exercise 3 becomes a little bit more interesting, and you can read it here. We're asked to find the location of the vertex, the highest point of a parabolic trajectory, and using this equation that the v is the vector, or is the velocity vector at any given time. The inner product of the velocity vector with the gravitational vector is going to be 0 at that high point. So we explore a bit as to why that should be true before actually solving or presenting or deriving rather the equation that Hestenes requests. So after that it's nothing all that interesting. Number 4 does become a bit more interesting. We are given that a target is at an elevation y above the launch point, and we're asked to find the maximum horizontal range that a projectile with a given initial speed v0 can reach on that horizontal plane here. And we go into different aspects of this problem to find out, well, can we really just use the equations that Hestenes has derived elsewhere in this section? Are these really the ones that apply? And because of some of those doubts, we go beyond Hestenes' own solution and actually identify the launch direction that's needed to attain that maximum direction, and thereby to confirm that at this target point here, the velocity vector will be perpendicular to the launch vector. The next problem, is quite similar in its statement. We're asked to find it's somewhat the converse. We're asked to find the minimum initial speed v0, the launch speed, needed to reach a target with horizontal range x and elevation y, and also a few things about the firing angle that's necessary, and the time of flight, and the final speed v, or the speed upon striking the target. We're asked specifically to derive these equations. So we do that here and explore a few more aspects of this to find out whether The equations that Hestenes presented for a slightly different purpose are the ones that also work here. Exercise 6 is rather different from these two equations, that the outer product of the velocity at any given time with the gravity vector is equal to the initial launch vector, its outer product with the gravity vector, and this other one that you can read here. From these equations, we ask to derive this one. And in order to do, or Hestenes' suggestion in his solutions, is to use an equation that he calls a Jacobi identity, or at least it has that form, and also the fact that the vectors are coplanar. And the explanation of why the coplanarity of the vectors is important is a good one to explore, and we do that here. So those are the solutions, and again, you can find the document and actually go through all these details. So I hope that you will consider joining our LinkedIn group, whose link is in the video description. And again, I encourage you to be free with your critiques and comments. Thank you for your time.